Hello everyone, my name is Flavio Grazian and it would be a great pleasure for me to walk you through the eBRT 2030 project. I am a project manager working at the International Association of Public Transport in the Knowledge Innovation Department, specifically at the bus unit, where we deal with innovation in urban bus systems. And it is a great honor for me to be able to introduce you to the eBRT 2030 project, which is a EU-funded project that focuses on innovations on electric bus rapid transit. The project started in January 2023, and it brings together a consortium of public transport operators, authorities, tech suppliers, infrastructure provider, research association and networks, as well as different stakeholders that are involved in the public transport environment as a whole. It is coordinated by UITP with the technical management of the VUB, which is the Flemish University of Brussels. What is the main objective of this project? It is to create a new generation of bus rapid transit that are fully electric and that are enhanced with novel functionalities in terms of automation or connectivity. It is really seeks to demonstrate in real operation these new innovations and these new solutions for electric bus rapid transit, and ultimately aims to decrease the costs, the TCO, and contribute to sustainable mobility by reducing greenhouse gas and pollutant emissions, as well as traffic congestions in our cities. It runs for 48 months, so for 4 years, until the end of December 2026. So one of the main important aspects of this project is to understand why all these partners came together and the EU decided to put a very big accent and highlight on innovation on bus rapid transit. At UITP, we have a history of dealing with innovation and third-party funded projects that contributed to the evolution of urban bus systems. And what we have seen is that throughout the past decades, BRTs, so bus rapid transit, can be really be the step forward in terms of innovation in urban mobility, particularly when they are combined with electromobility and with the new technologies that now are coming to use. So we really believe that this project can be the next brick to advocate and demonstrate the innovative solutions that when applied to bus rapid transit can provide innovative but also efficient and optimal services to our citizens. So the E in this context of this project stands for both European and electric, and we need to address this element in both ways. Of course, we are very much aware there are still challenges when we talk about electromobility in bus systems. At the same time, we do believe at UITP that this represents a great opportunity to implement innovative solutions and also optimize the existing systems. And this is precisely why we came together with all these partners for this project. So what are the key objectives of the eBRT 2030? So the first one, as I mentioned, is to develop innovative solutions for BRTs. These innovative solutions are at the level of the vehicle, the charging infrastructure, the operations, and of course the connectivity with the systems. Then the project wants to demonstrate these innovations in 6 different cities in Europe and 1 outside Europe. So these demonstrations basically are in real operation, passengers, and they specifically focused on addressing certain issues or to improve the level of services of existing BRTs. And finally, with this project, we would like to contribute on a thematic aspect, so the definition of what European BRT should look like ahead of the year, going towards the year 2030, benefiting from the evaluation, the replication, but also the assessment of the demonstrations and the test of the related innovations. So this is where we are with the project. So probably this slide is a bit not super clear because we are really already in the more than second part of the project. But as you can see from this slide, basically we started from the preparation with some definitions of the state of the art, the analysis of the requirements, the validation strategy, and the framework for the definition of the assessment models. Then the second phase focused on the development of the innovations, so the different innovations that eventually are being implemented in this moment in the different use cases and will be demonstrated in real operations. The last phase will be related to the validation of these innovations, and then of course also the replicability aspect of the cities, because the city has a lot of different spin-offs and different platforms to further multiply the results of the project. So the first step, as I mentioned, was the definition and the analysis of the state of the art, and the first report that this project contributed to create was this concept for the year 2030, and this is the first brick towards the definition of this concept. So this report is called On the Road to a Concept for BRT, and in this report we basically characterize the different BRTs. We analyze what has been implemented worldwide. We propose a definition and some scorecards for evaluating the different systems. It's not an evaluation in terms of like grading the marks on the different system, but rather more to showcase the areas of strength and the possible areas of improvement. So we define some qualifying criteria for what a bus line or corridor is in relation can and needs to be for being classified as a BRT. And I would really invite you to go and read this report because it's quite interesting and provides a lot of information. These are the demonstrations of the project. So you can see that we have Barcelona, Amsterdam, Prague, Athens, Rimini, and Bogota. Plus the project is now implementing a new demonstration in Nantes in France. What I think is very interesting here and needs to be specified that these demonstrations are divided in electric bus systems, but we also have in-motion charging trolleybus systems, specifically in Prague and Athens and Rimini. So the very interesting things in that, of course, when we talk about European bus rapid transit, we know very well that have a very specific application and can be quite different on the concept of BRT that developed originally from South America and also in Asia. So of course there are different elements of these systems, but this demonstration and innovation that are being implemented really needs to address specific issues for these lines in this specific context, or to improve the efficiency and the capabilities, the reliability of the systems of the system here in these different cities. So these are the technological innovations that we are implementing. So as I mentioned, these are clustered under 3 levels. So the level of the vehicle, the charging infrastructure, and the connectivity. What I think is very interesting is that innovations, hardware, software solutions, really, as I mentioned, they aim at improving the efficiency level or address specific issues in the demo cities. Then we also have in these projects what we call the tech to op, which are basically industry-led demonstrations that are demonstrating a static environment. And I think also these are very interesting because they also contribute to progress the level of technological readiness levels of these innovations. So we have some innovative hybrid battery concept, a smart narrow navigation, and some advanced static recharge systems that are currently being tested. Of course, we cannot enter into all the innovations that are being here demonstrated, but what I think is interesting for you is perhaps to provide some example. So here I selected, for example, intelligent driver support and safety system, or advanced energy and thermal management. There are in-motion charging systems. And to provide you an example, I want to just showcase a couple of demonstrations here where these innovations that I mentioned are currently being implemented. So here, for example, in Barcelona, we're optimizing the level of service of the H12 line. Why? The specific issue there was that because of the configuration of the traffic flows of the cities, there were regular bus disruption and therefore irregular arrivals and stops, unstable time and headways, and bus bunching. So what we implemented here, what the partners are implementing here, the leader is TMB, the public transport operator of Barcelona, is a traffic light priority and intersection plus a speed motion that is calculated with the simulation models and services to anticipate the different traffic scenarios. They are connecting the bus control center with the municipal control center for activating at request traffic light priority at several intersections when disruption occur. Additionally, they're also implementing some predictive maintenance for the fleet, which is quite important to optimize and decrease the costs, taking into consideration the technology and the artificial intelligence that can be of help in this case. For each innovation, there are a group of partners. So as I mentioned here, the leader is TNB Barcelona, but there are also the UPC, which is the university, also some other partners, the OEMs, Irizar is the ODM, but also Tecnalia. So it's really a consortium of different partners for the different demos. Another important demonstration is here in Prague that concern the airport line 119. So this it's quite a big achievement of the project because basically this eBRT line has been implemented ex novo thanks to this project and other source of financing, of course. The main idea is that DPP, Public Transport Operator of Prague, is now connecting the airport to the closest metro station with a in-motion charging trolleybus of 25 meters BRT systems. So this is very important because we are demonstrating that a high capacity bus is a double articulated bus, fully electric with an in-motion charging ratio of more than 50%, and opportunity charging at the terminus, so at the airport and at the metro, can really be key in connecting a facility such as the airport to the city, where there are a lot of passengers arriving, with a great headways in peak times of a bus every 3 minutes. Of course, this is quite important because the line started in operation in March 2024, and it since has been really a great improvement for the people visiting Prague or traveling from the city to the airport. Another interesting demonstration is the one that we are doing in Rimini, led by Start Romagna, the operator of that area. So here we are doing some, the partners are doing some innovations on the in-motion charging Metro Mare, which is a beautiful example of eBRT running along the coast of Romagna, between Rimini and Riccione. It's a fully segregated eBRT, and the innovations are related to different aspects to increase, for example, the resilience of the system by setting up a backup control center for the management of the system. We are also doing, they're also building an integrated charging hub to increase multimodality, a real-time passenger counting with a predictive forecasting customer load models to adjust the system, and an interesting automatic truck road safety that is quite key for them, because they want to detect the intrusion in the corridor. Here, another important element is to say that the line has been very successful. The system has been very successful since the start of its operation, and now they're planning an extension of the system, and possible another extension as well is in the pipeline. So the project has been also developing a lot of interesting tools. One of these is a simulation platform for eBRT that has been developed by the colleagues of VUB. This is a simulation platform for implementing feasibility studies, but also to simulate models and different elements for operators or authorities that seeks to either electrify their system or improve their system, or think to implement a new system ex novo. As you can see from the platform, there are different elements and configuration that can be simulated on different conditions, such as the speed profile, the battery conditions, passengers load, environmental conditions, weathers, the charging characteristic. It's a very highly scalable framework, and it can include the simulation of different routes. And the main ambition here is to bring some improvements thanks to this platform to minimize the TCO and energy use, and to optimize the system itself. What I think it's also very interesting is that this project is really looking also internationally. So as I mentioned, we have an international demonstration in Bogota, but as also there is an international cluster of small-scale demonstrations that will take place in Buenos Aires, Curitiba, Kigali, and Cape Town, so Latin America and Africa. We also have follower twinning cities that will perform feasibility studies. And these cities are Amman, Lagos, Lviv, Addis Ababa, and Merida. We have a user group, which is a group of PTOs and PTAs that are following this project, and basically they participate in study tours around Europe to study the implemented BRT system. They meet 2 times per year, and they also have a chairman, so they do very interesting study tour. And the main ambition of this user group is really to see and to upscale the implementation of BRT systems around. We've really seen now as UATP that there is a great interest around this topic and these systems. So many more are under developments. Thinking, for example, Portugal or Italy. So that's very good news. And of course, we also carry out these international activities to provide feedback to the European demonstrations themselves with different perspective on the technologies implemented, but also the operations that are very specific according to the context. What I think it's very interesting, it is that of course one of the main ambition of this project is to reduce cost, efficiency, but also look at the circularity perspective and the life cycle assessment. When we refer to public transport, we do really believe that BRTs in this can be extremely efficient. First of all, because when we talk about land use, we increase the efficiency of the speed of the bus thanks to priority measures that a BRT should receive. And also we want to implement a methodology to evaluate how the products and the system keep the materials as a value in use for as long as possible. So there are innovation focused on the optimization of life cycles of the batteries and this kind of resource efficiency, such as the battery reuse, lifetime extension, and optimization. So it is quite a big part also of the work of the project, and we really do believe that is a key element when we talk about innovation in electric bus systems. So we know very well that by 2030, at least 90% of new city buses of the youth must be zero emissions, but we need to consider that zero emission buses are not automatically zero impact, because of course we're talking about tailpipe emissions, but we need also to reduce and shift upstream. So at the beginning of the value chain, when, for example, we talk about manufacturing and batteries, EU is quite import dependent for electric vehicles batteries, and energy efficiency is quite critical. The electricity mix does play a role, and the EU rules are shifting the focus from compliance to full life cycle performances. So how this concretely means for this project is that the BRT innovations at 3 different levels, they need to demonstrate basically the improvement in terms of the elements that we mentioned before. So energy efficiency, utilization, lifetime, and maintenance. Eventually, the LCA and the circularity assessment in the eBRT innovation will highlight how this innovation will reduce the full life cycle footprint of the buses and trolleybuses in use in the demonstrations of this project. The mid to long-term outcomes of the project are, of course, the validation of the technological solution in the use case, the impact assessments of the operational concept and business models analysis for a market for eBRT solutions and innovation for future replication. Conceptual work, as I mentioned at the beginning, is one of the main objectives. So the project will develop a policy chapter to support decision maker in understanding the innovative BRT system and consider it as a possible mobility solution to be implemented in different cities. But overall, we want the project to improve the understanding of operation costs and environmental impacts, as it is important when we talk about TCO and LCA models. And also have 5 feasibility studies from the twinning cities, business models developed, and 3 technological to operation. So this study cooperation led by the industrial partners. It is quite important to consider this project as the consortium very fully committed has the aim to really optimize and increase the efficiency of the whole public transport ecosystem, but we want to stress how giving priority to buses and increasing the efficiency of BRT system can really produce a model shift as well towards public transport use and therefore increase the sustainability of our cities. A very quick slide to stress the importance of giving space to buses in our cities is one of the classical examples when we talk about circular economy of how much cars are dominating the use of public space in our cities, but they're very much a low efficient element. Typically, a car in Europe is parked 92% of the time and carries, in the slide we can see 1.5 people per trip. I think is an overestimation. In Europe is more 1.2, 1.3. So nonetheless, the location of public space that we have in our cities is up to 50% for cars, both including parking and the street themselves. So what we want to stress is that BRT makes infrastructure more efficient for an increased sustainable model of urban planning. And we need to consider this because of course how we utilize the public space of our cities, it is changing, but one of the most efficient way to change it is to give more space to buses. And particularly when we talk about bus rapid transit, is a bus that is more efficient, is more reliable, and optimize the use of public space in terms of energy and passenger flows. My last slide, and to conclude, is that the expected impacts of this project are increased ridership and, of course, operational performance. BRT is a bus system that performs well, is more reliable, and therefore it can be extremely helpful for citizens for their daily life. And of course, this goes in hand with the reduction in emissions, traffic, and increased shift, as I mentioned, towards sustainable mobility. Eventually, because of these innovations demonstrated in this project, we also have a reduction of costs, but also energy savings that are quite key in a context of an increased electromobility use. And I would like to thank you very much for your attention, and I hope you found this presentation interesting. We really do believe that projects such as this one can be a catalyst for change in different cities in Europe and around the world. Thanks so much.